This video is on the topic of potential difference and electromotive force. We know that electrons are negatively charged, and so they are attracted to the positive terminal of the cell. We also know that like charges repel. Therefore, the negatively charged electrons are repelled by the negative terminal of the cell. So what happens when the electrons pass through the cell? How do they get from the positive terminal to the negative terminal? How do they overcome the repulsive electrostatic force? Remember, for an object to have a positive charge, there has to be a lack of electrons. Positive charge cannot move because the protons are in the nuclei of atoms. Only electrons can move around. So to get electrons flowing in the circuit to move from the positive terminal to the negative terminal, work has to be done on the electrons to push them towards the negatively charged terminal. And that requires energy. That energy comes from the chemical store of the cell. The cell is the driving force that makes the charge flow. Without this, there is no current. So energy is transferred into the circuit from the cell, and energy is transferred away from the circuit by the components, such as a lamp. Therefore, it can be said that energy is transferred from the cell to the components. Electromotive force is the work done by a power source in moving a unit of charge around a complete circuit. That's the work done, or energy transferred, per unit charge. Potential difference is the work done by a unit of charge passing through a component. That's work done or energy transferred per unit charge. Both are measured in volts. Things get a little more complicated when you get to A level, but for now they are essentially the same thing, numerically speaking. The difference is that EMF is the energy transferred to the circuit, and potential difference is the energy transferred away from the circuit. You only need to know these equations if you're studying the extended content. We know that an ammeter has to be positioned in series so that the charge flows through it. An ammeter counts the amount of charge passing through it per unit time to give a value for current. A voltmeter works very differently. Let's say that the potential difference of the cell here is 1.5 volts. That means that the positive terminal has an electric potential of 1.5 volts and the negative terminal is 0 volts. So this wire, up until the component, is 1.5 volts. And this wire, up to the component, is 0 volts. A voltmeter measures the potential difference, or the difference in electrical potential, between 2 points in the circuit. Think of the branches or wires on either side of the voltmeter being like arms grabbing onto 2 different points in the circuit. It measures the potential difference between these 2 points. For that reason, a voltmeter has to be positioned in parallel to the component it's measuring. It has to be connected to 2 different points. Let's apply this understanding to an example exam question. Which row of the table correctly shows the readings from the voltmeters in this circuit when the cells in the battery are 1.5 volts each? Okay, so we know that the potential difference of each cell is 1.5 volts. And we have 2 cells in the battery. That gives us a total potential difference of 3.0 volts. There's a very easy way to figure out the potential difference at any point in the circuit, and that is to color the branches. So if we follow this branch at 3 volts all the way to the components, and if we follow this branch at 0 volts all the way to the components, then we can clearly see that voltmeter 1 reads 3.0 volts, voltmeter 2 reads 3.0 volts, and voltmeter 3 reads 0 volts, nothing. Therefore, the correct answer is B for 1 mark. A couple of things to pick up on here. Firstly, voltmeter 3 reads 0 because it's positioned in series. But even if it were positioned in parallel, we can see that there is no difference in electrical potential in this branch. both arms of the voltmeter would read the same 0 volts. And secondly, what would this section be between the resistors? Assuming that the resistors are equal in value, then the energy transferred to each one from the battery would also be equal. Therefore, half of the energy would be transferred to the first resistor and half the energy would be transferred to the second resistor. If we were to add a voltmeter in parallel across each of these resistors, we can clearly see that they would both read 1.5 volts. In summary, the cell has two roles within the circuit. Firstly, the electromotive force. The cell drives the current around the circuit by doing work on the electrons to overcome the repulsive electrostatic force. Secondly, the potential difference. The cell transfers energy into the circuit and the components transfer energy away from the circuit. So it can be said that the cell transfers energy to the components. Voltmeters measure the potential difference between 2 points in the circuit, and to do this, they have to be connected in parallel. And finally, remember that you can easily find the potential difference at any point within any circuit by coloring the branches from each terminal of the cell, battery, or power source. Don't forget to check out all our other fantastic revision resources here at Save My Exams.